Last class, we started word problems with sinusoidal graphs, but that was more like I would give you a graph and we would interpret it. In today's class, what we're going to do is we're going to sketch our own graphs. So it is going to come back to sketching, which we just did for our quiz, and then we're going to analyze them. So we'll get started. I just want to remind you of a couple of rules. So whenever you have a wheel, the radius of the wheel is the amplitude. The center of the wheel is the equation of axis. From the maximum to the minimum is the diameter. And what else did we learn? One period on a graph refers to one revolution of the wheel. And we can figure out speed because speed is distance over time and distance is just the circumference of the wheel. So that's everything we learned in last class, which we're going to need in today's class as well. Sketch a height versus time graph of the sinusoidal function that models the following situation. So we have a water wheel, and I've kind of shown you a picture of it. And it has a radius of 3 meters, whose center is 1 meter below water, and it rotates once every 60 seconds. Assume that we draw the graph at the lowest point of the wheel. So before we start graphing this, let us note down all the important information. First of all, if the radius is 3 meters, what does that mean? Good. So we're going to write down amplitude equals 3 meters. If the center of the wheel is 1 meter below water level, we're assuming the x-axis is the water level. So what does that mean? The center is 1 meter below. What are we going to write? Equation of axis, and that's going to be good. So equation of axis is going to be y is equal to -1. Okay, now it says it rotates once every 60 seconds. So that means the period of this graph is going to be 60 seconds. And we can use that information to figure out our quarter period, which is just going to be 16 divided by 4, and that's going to be 15 seconds. So something important happens every 15 seconds on this graph. Oh gosh. Okay, so let's go ahead and start graphing it. We basically have an equation of axis of -1, amplitude of 3. So we need to go up to a maximum of 2 and down to a minimum of -4. Period is 60. How many cycles should we, I guess we could just stick to 1 or 2 cycles. So every 15 seconds, something interesting is happening. That means we're going to have 15, 30, 45, and 60. And if you wanted, we could keep going for another cycle. So 75, 90, 105, and I've run out of room. 105, and then 120. Okay, because this is modeling like something that's real life, we also need to label our axes. So our y-axis, I'm just going to put it at the top over here. This represents our height in meters, and our x-axis represents our time in seconds. Yeah, yeah. Okay, what am I going to begin with? I'm going to start off by labeling my equation of axis. So at y is equal to -1, I'm going to go ahead and make a dashed line. And I'm going to pause this for a second. Okay, so our equation of axis is y is equal to -1. We can from here, this, you guys, you did so well on the quiz. I know we all know how to do this. So our amplitude is 3, which means our maximum is going to be at the 2. 1, 2, 3. Our minimum is going to be at -4. And now we just need to draw out our curve. So how exactly are we going to do that? Well, the question says we're going to start at the lowest point of the wheel. So we're basically going to be starting at our minimum. That's the lowest part of the wheel. Then after 15 seconds, we're gonna go to the equation of axis. After 30 seconds, we're gonna go to the maximum, then equation of axis, and then back to the minimum. And then we're gonna repeat that for one more cycle. So because they said start at the bottom of the wheel, and then when we draw it, you can see it's actually a negative cosine graph. So for any sort of word problem, it will tell you where you're starting from. So like in the Ferris wheel, it'll say the person gets on at the bottom of the wheel or the top of the wheel or wherever. So I've drawn it for 2 cycles and that's it. That's literally what we're going to do for every single question. We're also going to be answering some questions like once we draw it. This one just required us to draw it, but we will analyze as well. Not too bad, right? We're basically taking transformations in the lesson yesterday, grouping them together, and now we're solving. All right, let's go on to question number 2. Question number 2 says, a Ferris wheel has a diameter of 20 meters. So keep in mind, if it's a diameter of 20 meters, it means it has a radius of 10 meters. And the radius is important because that's going to give you the amplitude of the graph. The center is 12 meters above the ground. That means it's going to tell you where the equation of axis is. It makes one complete rotation every 60 seconds. Sketch the graph of the height of a rider for one complete cycle, assuming they start at the lowest point. By the way, for the time, if x is time, can it ever be negative? No. So when you're drawing your x and y, just be mindful of like where the lines are going to go and stuff like that. All right, I'm going to begin by writing out my information. So I know for this question, the amplitude is going to be equal to 10 meters. I also know the equation of axis is going to be at y is equal to 12. The period is the same as before, 60 seconds. That means the quarter period is going to be 60 divided by 4, which is going to be 15 seconds. If I were to label my axes, time will always go on the x-axis. And then what else do we have? Height of a rider above the ground. So you can say just height. There's a spider on my. And the height is going to be in meters. Okay, so our equation of axis is 12, and then we have to go 10 above and 10 below. So you're actually going to go all the way to 22. You can decide how you want to do that. I'm just going to go up by 2s. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, and then 22. Yeah, I mean, you can go up by 1s if you're like, if you have enough room, but that is totally up to you. And then just like before, maybe for this one, we'll just do 1 cycle because I think we get the hang of it. So we're going to go 15 seconds and then 30 seconds and then 45 seconds and then 60 seconds. All right, so I'm going to go ahead and draw my equation of axis, which is 2, 4, 6, 8, 10, 12. So it's going to be there. Oh, gosh. There we go. And is this even 12? Watch me have messed it up. 2, 4, 6, 8, 10, 12. Yes, it is. I'll be right back. Relaxed unit. All right, so y is equal to 12 is my equation of axis. I know that my maximum is going to be 22 and my minimum is going to be just 2. So I'm going to label those. That's my maximum. That's my minimum. Now we're ready to start. So the question gives us a hint as to what exactly we're going to be doing because it says that the person starts at the lowest point, right? So we're gonna start at a minimum. That's gonna be our first point. Then the maximum is 22. We're gonna go to 15 and the equation of axis, which is 12. And by the way, I can label the equation of axis too, because I haven't labeled a lot in this. So I'll just label that. And then we're gonna go to 30 and the maximum, and then equation of axis, and then back to the minimum. Oh, it's still a little shaky. Okay, one more time. If I don't get it this time, that's good enough. That's it. Now, one thing that we can do, by the way, does anyone have any questions? Does this make sense? All right, we can actually answer a bunch of different questions. It says, determine the sinusoidal equations to model the situation, indicate the initial point of the graph. So this is the lesson we did on Monday, where when you've been given a graph, figure out the equation for it. So to do this, I'm gonna go y is equal to, it's definitely a negative cosine graph. So it's gonna be negative, the amplitude is 10 cos. And now what I need to do is I need to figure out my K value. So as a reminder, the formula is your period is equal to 360 divided by K. So K is equal to 360 divided by the period. So we're just going to go 360 divided by 60, which is just going to be the number 6. So in here, our K value is going, so I'll just write it here. K is equal to 6. So this will just be 6x because there is no phase shift. And then we're going all the way up to 12, which is our equation of axis. Raheem, when you had a question? What is the height of the rider after 48 seconds? So obviously, if you use the graph, it would not be very accurate. Now we're going to be using our formula to figure everything out. Marzu? After you figured it out? Yeah, you could. I actually didn't take off any marks for that on the quiz, but it would be smart to label it after. Yeah. Okay, so what is the height of the rider after 48 seconds? For this question, we're going to be putting in x is equal to 48 and then literally just using your calculator to solve it. Okay, so getting to be like a little bit tense. So this is x is equal to 48 seconds. Y is going to be equal to negative 10 cos 6 times 48 plus 12. So we're going to go 6 times 48 is 288 cos 288. Make sure it's in degree mode times negative 10 plus 12. And let's just round everything to one decimal place. So 8.9 meters. So the height of the rider after 48 seconds is 8.9 meters. Question D, suppose the Ferris wheel makes 3 complete cycles per ride. Determine the domain and range in terms of the situation. Okay, so how would we do this question? What we would do is, first of all, the range is really easy for any sinusoidal function because it's just the maximum and the minimum. So I'm actually going to start with the range. I'm going to say the range is the set of all y values, and it's basically between 2 and 22. So it's going to be y is greater than or equal to 2, y is less than or equal to 22, and y includes all real values. For the domain, we have to think a little bit because look, we start at 0 and we end at 60. That's the first cycle. Then another 60, then another 60. So that's going to give us how much for the domain? 180, yeah. So we're going to say the set of all x values such that x is going to be between 0 and 180. X includes all real values. All right, 2 more examples together than one by yourselves. One day, the water level at the tip of the Bay of Fundy varied by 12 meters between high and low tide. Does anyone know where the Bay of Fundy is? Yeah. I went there once too. It's actually really cool. It's in the east, it's on the East Coast, and it's an area where if you go there during low tide, you can walk out like 2 kilometers, but then during high tide, the water fills up and it's like 20 or 12 or 20 meters higher. And the reason for that is because the gravitational pull of the moon just tends to be stronger there. So what's happening is like you can go there in the morning at 12 o'clock and then you'll be able to walk through and it's fine. And when you come back at like 9 p.m. or something, the entire area is filled with water. It's actually pretty cool. So one day the water level at the tip of the Bay of Fundy varied by 12 meters between high and low tide. One cycle is completed every 12 hours. The first low tide that day occurred at 12 a.m. and measured 2 meters deep. Draw a graph to show how the depth of the water changes over the next 24 hours starting at 12 a.m. So we're going to have to use times for the x-axis. Let's first list all the information that they've given us. So first of all, what would be the amplitude? 12 meters is from maximum to minimum. Yeah, so the amplitude would actually be just 6. What would be the equation of axis? So you're assuming that the low tide is 2 meters and then it gets all the way to 12, sorry, it gets 12 meters higher than that. So it starts at 2 meters, it gets all the way to 14 meters. That's the high and the low. So you're gonna go 14 plus 2, which is 16 divided by 2, which is 8. So our equation of axis is gonna be y is equal to 8. Yeah. So 12 meters is from low to high tide, and the first tide is at 2 meters. So basically it starts at 2 and then it goes 12 meters higher, which is going to be 14. To figure out the equation of axis, I just added those numbers, 14 plus 2 to get, yeah. And then we know that the period is going to be every 12 hours. That means the quarter period is going to be every 3 hours. Okay, so equation of axis is 8, then I'm going all the way to 14. So basically you're going from 0 to 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 1, so minimum is 2, 2, 3, 4, 5, 6, 7, 8. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And then we basically have to start from 12 a.m. and then go for 24 hours. So what I'll do is I'll actually go up by 3 hours because that makes the most sense. So the starting time here is going to be 12 hours. Let's write 12 a.m. And then we're going to go to 3 a.m., then 6 a.m., then 9 a.m., and then 12 p.m. And then 3 p.m., and then 6 p.m., and then 9 p.m., and then back to 12 a.m. How did I know to do that? Well, it says the first low tide occurred at 12 a.m. So I have to start from 12 a.m. And then they want 24 hours. Why did I go up by 3 hours? Well, because my quarter period is 3 hours. So that'll make it really easy when we're graphing. We basically just have to go shift over every 3 hours. Okay, I need an equation of axis drawn. So that is going to I went up by 3s. And from 12 a.m. to 12 a.m. Okay, so the equation of axis is as y is equal to 8. Our maximum is at 14. Our minimum is at 2. And also, because this is a scenario, I do need to label my axes. So it says draw a graph to show how the depth of the water. So this is going to be depth, which is going to be in meters. And this is going to be time, which is going to actually be in hours. All right, we're ready to graph. So here's what we're gonna do. We have to start at, so the first low tide occurred at 12 a.m. That means you definitely have to start at the minimum. And then after 3 hours, we're going to go to our equation of axis. Another 3 hours, go to your maximum, then axis, then minimum. So basically, this means that at 12 a.m., the water was at 2 meters. But then after 6 hours at 6 a.m., it went all the way to its maximum height at 14 hours. And then another 6 hours later at noon, it went back to the minimum. So it takes 12 hours for it to go through the cycle. And we'll draw one more because it said 24 hours. And that's what the graph is going to look like. Together. Question number 4, a small windmill has its center 6 meters above the ground. So if you visualize a windmill, I've kind of drawn a picture here. Windmills are never close to the ground. Obviously, they need wind. So you make like this stand and then they're sort of floating in the air. So in this question, you're going to visualize that the windmill has a center 6 meters above the ground. And then the windmill itself, the blades are 2 meters long. In a steady wind at point P at the tip of one blade, it makes a complete rotation in 12 seconds. If the rotation begins at the highest possible point, sketch the graph. Okay, so we need to think about this for a second. We have the windmill here, and then let's say it looks like this. From here to here, it's 6 meters. So that means where are we going to draw our equation of axis? 6 meters. And then what is the amplitude going to be? Good, because basically from the center to the top, the radius of the wheel is 2 meters. Good. All right, so now that we have that information, let's fill it out over here. I'm going to say amplitude equals 2 meters. The equation of axis is going to be y is equal to 6. The period is every 12 seconds. And so the quarter period is every 3 seconds. Because the blades are 2 meters, and that's like sort of the radius of the windmill. So we're basically going, I don't know why, you know what, I can actually move this down because we can't have a negative. It's not like you can have a negative thing. All right, that's better. So I'm basically going to go all the way to 8. I'll measure by 2s. So 2, 4, 6, 8. And then for my y-axis, I'm going to go up by 3s. How many rotations should we do? If the rotation begins, does it say? Doesn't really say. So let's just do 2. So I'll go up by 3s. 3, 6, 9, 12. 15, 18, 21, 24. My y-axis is going to be time in, or my x-axis is going to be time in seconds, and my y-axis is going to be, oh, it's actually height above the ground. I think that would be the best way to describe it, or just height. Oh, it doesn't matter. I just don't have a lot of it yet. Okay, so our equation of axis is at 6. Our maximum is at 8. And our minimum is at 4 because just the windmill itself isn't very big. It's just 2 meters. Now we're ready to graph. So in this question, though, it says that point P is going to be at the highest possible point. So we're going to start at the maximum. Then we're going to move over 3 and go to the equation of axis, and then the minimum equation, and then maximum. So that's one complete cycle of the windmill. Starts at 0, ends at 12 seconds. It takes one complete rotation at 12 seconds. Yeah, because it says start at the highest point. And that's what the graph's gonna look like. A couple of questions about this. Question B says, determine a function that gives the height of the point P above the ground at time T. So we are just trying to figure out what the equation will be. I always start by figuring out my equation just in terms of y and x, because I think that's a little bit easier. And then I use the letters that they're saying. So I know it's going to be y is equal to, for the first part of the cycle, it's just a positive cosine graph. So it's going to be cos. We need to figure out our k value, which is just going to be 360 divided by 12. So I'll write it on the side. K is going to be 360 divided by the period. And so K is going to be 30. There is no shift. And then it's going to be plus 6. So 2 cos 30x plus 6. Now they did say use P and T. So I'm going to say P of T, it's just function notation, is going to be 30t plus 6. And then the question C says, what is the height of the point P at 5 seconds and 40 seconds? We're basically plugging in when T is 5 and when T is 40, and we're using our calculator to solve. Okay, so I'll do the first one here. When T is equal to 5. And then this one will be when T is equal to 40. All right, so we're gonna have P of 5 is equal to 2 cos 30 times 5 plus 6. So 30 times 5 is just 150, cos 150 times 2 plus 6. We'll round it to 1 decimal place. It's going to be 4.3 meters. And this one will be P of 40 is equal to 2 cos 30 times 40 plus 6. And that's going to be cos 1200 times 2 plus 6. That's just going to give us 5 meters. That makes sense, actually, because, well, anyways. Yeah, I'll keep it here. Once you're done this, just go ahead and, before you do anything else, just do the last example as well, and I'll show you the answers. And then the only homework for this section is a textbook question. I'll show you guys at home the last question in a second. So it says, the tides in a small fishing village can be modeled using the function h is equal to 6 sine 30 bracket t plus 2, where h represents the height of the water in meters and t represents the time in hours after noon. Okay, so I know right away that my height is in meters over here, and my time is going to be in hours over here. Graph the equation over a period of 24 hours. Okay, so let's first figure out what information they've given us. We know the amplitude is 6. We know the equation of axis is just going to be y is equal to 0. Then to figure out the period, we're going to go 360 degrees divided by the k value. So 360 divided by 30, which is just going to be a period of 12. And that means the quarter period is going to be 3 hours. All right, so if we were to graph this, 0 is here. I just need to go all the way up to a maximum of 6 and a minimum of -6. The phase shift is fine. You will start your graph at the negative time, but then it doesn't actually count. It just tells you the shape of the graph. So, okay, so I'll show you how to do that. Time 0 is noon, right? It says afternoon, and we're going for 24 hours. And we're shifting 2 times. to -2. So basically we're going -1, -2. And then we're going 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. Okay, so this is -2. I'll just label the more important stuff. Actually, I'll label everything. -1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, and 22. So basically what this question is saying is we start, this point right here is noon. Oh, before that, let's figure out our equation of axis. So we have y is equal to 0. Wonder if I can make this line dashed. Let's try it. Okay, I'm gonna have to pause this. I'm gonna struggle. Be right back. All right, you guys, so this is the maximum. I'm just gonna label that with this. This is the maximum, and this is the minimum. Finally ready to graph. Now, what's happening in this question is we start at, I need to highlight, we start at -2, right? Because the graph starts at -2. So we start here, and then every 3 hours, something important happens. So 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. I'll just follow the pattern. So we start at -2, then something important happens at 1 hour, 4 hours pass, 7 hours, 10, 13, 16, 19, 22. And by the way, if we're talking in terms of like timings, if 0 represents your noon, because that is what the question said, that means after 12 hours, this is going to be midnight. And then this is going to be noon again. Okay, so we begin over here, and it's the positive sign graph. So after 3 hours, we're going to go to the maximum, then back to the 0, then, hi Ben, then back to the minimum, then back to the 0, then back to the maximum, and then back to the 0, minimum, and 0. Okay, so it's going to look like this, like that, like that. Is that what you guys got? Now, the only thing is you technically can't have a negative graph. So just show some indication that you know that doesn't exist. You can even just make it a dashed line or something, just because technically you will never have that negative time. But you can have a phase shift. It just means the graph starts like at an awkward sort of place. I'll bring this back. I'm just going to answer the rest of the questions, and then you can check your work. Use the graph to determine when the first high and low tides were. So the first high tide was after a time of 1 hour. So at time of 1 hour, it's actually 1 p.m. because it said start your graph at noon, which is what we did. And so every hour after that is, and then the low tide is going to be at what time? Time is equal to 7. So it's going to be T is equal to 7 hours. Therefore, it's going to be 7 p.m. Oh, I really don't like these colors. Okay, what is the period of the function? It is just, we already calculated that. It's going to be 12 hours. Model the situation using the sine and cosine functions. So just make sure you are labeling where you're starting it from. Technically, the question's already given us the sine, so we don't really need to do the sine. We just need to do the cosine. So I'm going to start my cosine up here, and I'm going to end it up here. All right, and then the questions for homework are at the bottom there.